Welcome to the session 6 of Unit 4, that is construction of CNC machines in computer integrated manufacturing. In this class, let us see the feed drives. Feed drives. What do you mean by feed drives? They are the systems which provides the linear motion of to the slides as per the commands of ANSI system. As per the commands given by the machine control unit, these feed drives will cause the slide to move on the linear motion. Since the degree of accuracy is required is very high, hence they should have very high efficiency and quick response. They should be highly responsive and it should be efficiency should be high. These feed drives consist of servo motors and electrical control unit. So basically we are going to see what is this servo motor which is being used in feed drives. Generally we never use AC motor or a DC motors here. We use a servo motors. It's a unique motors which is being used in any CNC machines. That is why the CNC machines are costly because of this servo motors. So this servo motors are electronic control unit. Electronic control unit is one which converts the programming language into machine language. So machine can understand in a better way. So this is one kind of applications. So feed motors have certain special characteristics like constant torque and point-to-point positioning. So constant torque is very important. So constant torque is that so the speed is constant and it can point-to-point positioning exactly the required position it is going to maintain. Feed drives will actuate the slides. The slides are actuated by the feed drives. So this is one type of things I can say. The feed requirements of feed drives. So the following are the requirements of feed drives. One such requirement is it should have constant torque. So this is very important, the speed and rotation with respect to force. It should maintain the constant torque. The drive speed should be indefinitely variable. So this is very important. In AC motor, variation in speed is achieved. In DC motor, constant speed is achieved. When you want both, at certain programs we need constant speed, at certain program we need variation in speed. This indefinite variable speed is combined, both AC and DC functions can perform only by one motor, that is known as servo motors, that is incorporated in feed drives. Maximum speed is up to 3000 rpm. So this is a basic model which you can say. Now it's gone to very high speed of 50,000 60,000 rpm. So today minimum CNC machines should speed up to 3000 rpm. So it must give very quick response, very important. The feedback, closed loop feedback system should be very high and high torque to weight ratio. So when the weight increases, the torque should also be very high, because on the machine the load increases, the torque should not reduce. This is the advantage of CNC machines. It has permanent magnetic construction. So so it is permanently fixed with a magnetic construction. So the one servo motor is fixed only for one machine. There is a dedicated machine. There is no problem. It should work smoothly. Definitely, any requirements of feed drives, it should work smoothly. Low electrical constants. Low electrical constants will be voltage means the VI characteristics, the volt ampere characteristics. So that it should have low electrical constants, so that it can easily move with respect to this. Next is known as servo motors. So as I said, DC servo motor is similar to shunt motor in construction. So these motors are designed to provide controlled acceleration, deacceleration. So variation in speed is also possible, constant speed is also possible, which is not possible in the case of conventional machines, because these servo motors are equipped in such a way that it acts like both AC as well as DC. So this motor provides excellent speed regulations with high torque and high efficiency. That is why the servo motors are special, because they provide high efficiency, high torque at a very high speed. So the load is very important. When the load increases, even though at a high increased load, this servo motors will give a high efficiency. That's why it is a unique feature of this. The servo motors. So these DC servo motors are also called as PM DC motors. That is a permanent magnets direct control motors, direct current motors. DC stands for direct currents. So at the same time, they are permanent magnetic servo motors. So they are widely used for fluctuations, speed fluctuations. So variation in feeds, as I said, so this can be taken care. the stator magnetic flux remains constant irrespective of the armature current speed. So what is this? So basically we will have two ways to control the speed of a motor. One is armature control and a field control. But here, irrespective of the field's armature current speed, we can maintain the flux. So the speed torque relationship of a motor is linear. Here there is a relationship is linear with respect to torque, speed and torque things. So the speed of the motor can be controlled in two ways. One is armature control and a field control. So in a servo motor, only two important factors, two way we can reduce it. One is the armature control, second one is a field control. So this is the only two ways we can do this way. So at this point I am going to stop at the session 6 of unit 4, construction of CNC machines. Dear students, thank you so much for your patience listening. Thank you.